power examples in the same video. All right, so we are going to look at these two power examples right underneath where it says Power Lab. So the first example says a stock worker lifts 30.5 kilogram cans per minute onto a 2-meter high shelf. What is their average power output? Now again, we're using average power because it's occurring over a period of time. And I have a choice on which way I want to find the work to plug into that average power. Now, because my cans are going from one point to another point, that is my hint that I'm going to be using the work kinetic energy theorem. So I set up my work kinetic energy theorem. There's work in, there's no work done by friction. The kinetic energy at the start and the end are both 0, so kinetic 2 crosses out, kinetic 1 cancels out. There is gravitational potential energy at the end. There is not at the start because I'm going to call this height down here 0, and there's no springs. So my work kinetic energy theorem gets pretty small pretty quick. So now I know that the work in is going to be equal to mgh. They did tell me the height, and they also told me the mass, but kind of in a construed way. So there's 30.5 kilogram cans. So in the end, this stock worker essentially lifted 15 kilograms altogether. So my mass is going to be 30 times 0.5, or the mass is a total of 15 kilograms. To find the power, I just need to do work divided by time. So I'm going to do mgh divided by time. So my power is going to be 15 times 9.8 times the 2 meters we lifted those cans, all divided by the time. And it said 30 cans per minute. So that means they did these 30 cans in a time of 1 minute or 60 seconds. And so we find out that the power output is 4.9 watts of power. All right, let's take a look at the next one here. So it says, what is the power output in horsepower? So we'll have to do a little conversion of a motor that lifts a 400 kilogram pallet of bricks at a constant speed of 0.75 meters per second. Constant speed got me thinking. Constant speed tells me that the sum of the forces in the y direction is going to be 0. Meaning if I put this into that equation, I find out that the applied force is equal to the weight of those bricks. All right, so if I know a force and I know a velocity, I can find that instantaneous power. All right, so the power is going to be this force, which is m times g, times my velocity, and so I can plug in that information. They told me the brick pallet was 400 kilograms, so 400 times 9.8 times the speed of 0.75 gives me a power output of 2,940 watts. And I do have to convert that, so I need to get rid of watts, go to horsepower. 1 horsepower is 746 watts. That conversion factor is up in the upper right-hand corner of your gold equation sheet. And we should find out that if we do this calculation correctly, it is 3.94 horsepower. So just shy of a 4 horsepower motor would be required to lift those bricks at that constant speed. All right, I think that's it for our examples.